Hello, everybody, and thank you for joining us today for Vertica Unify 2021. Today's breakout session is entitled Best Practices in Vertica Database Security. I'm Jeff Healy, and I lead marketing at Vertica. I'll be your host for this breakout session. Joining me today is Andrei Kirilenkov, Solution Architect at Vertica, as well as Chris Morris, who's part of our security engineering team. Before we begin, I encourage you to submit questions during the virtual session. Enter your question into the Q&A box on the right-hand side of the screen. There will be a Q&A session at the end of the presentation. We'll answer as many questions as possible during that time. Any questions that we don't address, we'll do our best to answer offline. Alternatively, visit the Virtual Developer Lounge to ask additional questions and continue the conversation with our engineers and product experts after the session. And yes, this virtual session is being recorded and will be available to view on demand this week. We'll send you a notification as soon as it's ready. Please stick around to get the code to gain points to participate in our Analyze to Win competition and win prizes. Now let's get started. Over to you, Andrei.
Thank you, Jeff. In this session, I'll be presenting the basics and the best practices in Vertica security. For diving deeper into this topic, please find the respective session in the agenda of the conference and attend it. Vertica offers a rich set of the security features, each of which answers a specific question. But which ones to select, how to build a particular solution based on them, all this depends on the use case and the threat model defined at the company. A threat model identifies potential security threats and vulnerabilities, quantifies the seriousness of each, and prioritizes the techniques to mitigate attack and protect the IT resources. It should be realistic. It should find the right balance between the security requirements and ease of use and implementation. In the COVID times, security is becoming a critical factor because the number of the cyber attacks is growing, as the worldwide experience shows. This talk will give you the basic understanding of how to create a secure architecture for your needs. The Vertica security features can be grouped by the questions to which they give answers. If we want to protect our data at rest, as they are stored in a database or in transit, we should select the way how we mask or encrypt it. Authentication, identification, authorization are usual steps for a database to understand who wants to connect to it, if a person has rights to connect, and what the person can do within the database. In many cases, Vertica connects to external applications and needs to have access to the resources which a Vertica user is requesting. In this case, we speak of the delegation or impersonation process where Vertica pretends to be a user. Finally, we should be able to keep under control the security-related features, monitor and manage them. Let's talk about protecting our data in transit. On this slide, you see a Vertica cluster consisting of 3 nodes and all possible data movements, both within and outside the cluster. First of all, data is moving between the nodes of the cluster. This can be data required for processing of a query, or it can be the result sets which executors send to the initiator, which in turn builds the final result set and sends it back to a client. Additionally, there is constant communication between the nodes. This communication is managed by a utility called Spread, an open source toolkit providing a high-performance messaging service. Spread is broadcasting metadata across the cluster using UDP protocol. Second type of data flow is related to all kinds of client connections to Vertica. For instance, a BI tool retrieving data from Vertica for a dashboard, or vSQL connection from a client machine, which a DBA is using for certain needs, etc. Third possible data flow is between different Vertica clusters, which can exchange data using special Vertica utilities. And finally, the external services integrated with Vertica can exchange data with Vertica. For instance, Vertica can query the Parquet data stored in HDFS cluster or in S3 bucket, or it can digest data continuously from a Kafka topic, etc. Obviously, all the data movements should be secure so that no one can intercept the data stream and read it. Not to lose the forest behind the trees, I have listed the supported client authentication methods on this slide. Vertica supports clients using either the IPv4 or 6 protocols, and we will take a closer look at the TLS method. Vertica users should be sure that access to sensitive information is closely guarded. For that purpose, Vertica as a server uses client authentication to establish the identity of requesting client and determines whether that client is authorized to connect to it. In Vertica, high security of the client-server connections is supported by Transport Layer Security (TLS), which prevents man-in-the-middle attacks. A client and Vertica can mutually authenticate each other, allowing no one to squeeze between them. TLS significantly reduces the likelihood that data can be read because the data moving between the client and server is encrypted and data integrity is verified. Vertica supports two modes, server and mutual. In server mode, the client must confirm the server's identity before connecting. The client verifies that the server's certificate and public key are valid and were issued by a certificate authority, CA, listed in the client's list of trusted CAs. This helps prevent man-in-the-middle attack. In mutual mode, the client and the server must verify each other's identity before connecting. To configure TLS in Vertica, we should set up two parameters, SSL certificate and SSL private key. If we set them up or modify them, they apply only to new connections. SSL private key is the key for the Vertica server certificate that was added in the SSL certificate parameter. It is visible only to users with administrator role. To use TLS for ODBC or JDBC clients, SSL mode connection property should be set. An example of the command to set SSL certificate is shown at the bottom of the slide. Intra-cluster data flow security is not critical if Vertica is running behind a strict and highly protected firewall, but it becomes highly important once the cluster is installed in a public cloud. And within a Vertica cluster, there are two channels. Control channel is used to exchange plan information and distribute calls. It is implemented using spread and UDP protocol, and data channel is used to exchange table data and is implemented using TCP protocol. TLS internode encryption can be enabled for spread and the nodes. By default, both are disabled. If internode encryption is enabled, some of the queries may run slower than expected, depending on the data sent. There is no general rule here, but this should always be taken into account when we tune the performance of a solution. One Vertica instance can easily import and export data to or from other instances. It is useful for common tasks, such as moving data back and forth between a development or test and a production database, or between databases that have different purposes but need to share data on a regular basis, or to move data between the dissimilar clusters, which is impossible to do with backup and recovery. When one of the involved Vertica clusters is not behind a reliable firewall, it is critical to secure export and import. When we import or export data, one of the clusters functions as a client, which means we can use TLS to protect the connection. Vertica can encrypt both data and plan metadata. Data is encrypted if internode encryption is configured. For metadata, by default, Vertica tries TLS first and falls back to plain text, but it is possible to configure it to require TLS and to fail if the connection cannot be made. To configure TLS between nodes, some parameters should be set. Encrypt spread com parameter enables all other TLS-related parameters and is set by alter database command. After the database is altered, it should be restarted and the security configuration checked. To specify the level of strictness when connecting to another cluster, set the import-export TLS mode global configuration parameter. This parameter applies for both importing and exporting data. Both clusters need to have the same data SSL params, which should be set with alter database command and can be verified by running a Vertica meta function security config check, as shown at the bottom of this slide. Let's move on to the security of working with external services, which does depend on the service itself. Some of the most often used ones are HDFS, Kafka, Voltage, SecureData, S3, both on Amazon and on-premise. For instance, Amazon defines two ways to control access to AWS resources such as S3, IAM roles and the combination of ID secrets and optionally session tokens. However, for one-time tasks like backing up and restoring the database or loading data to and from non-communal storage buckets, an AWS access key should be used. In Google Cloud, Vertica uses a hash-based message authentication code, HMAC, to authenticate requests to access the communal storage location. This key has two parts, an access ID and a secret. To work with Spark, we should set up properly the connection to HDFS. When transferring data to the Spark connector in Vertica, write data to a temporary storage location. Currently, the connector supports HDFS as an intermediate storage location. So both Spark and Vertica must be configured to access this location. Ease of use is one of the Vertica roadmap key directions wherever it is applicable. We plan to simplify and enhance the TLS configuration process. More security options are planned to be supported by default. While data in transit is traveling from network to network or being transferred from a local storage device to a cloud storage device, data at rest is not actively moving from device to device or network to network. It is data stored somewhere. While data at rest is sometimes considered to be less vulnerable than data in transit, attackers often find data at rest a more valuable target than data in motion. The risk profile for data in transit or data at rest depends on the security measures that are in place to secure data in either state. Encryption approach depends on a use case. The possible approaches are listed on this slide. Vertica supports the encryption provided in public clouds. On top of that, in Vertica, we can encrypt data on a column level. This is important if you need to manage keys yourselves and thereby make the data indecipherable to a cloud provider. The latter is implemented via integration with Micro Focus product called Voltage SecureData, or a suite of encryption technologies that enable integration of end-to-end data encryption into other applications. SecureData uses format-preserving encryption, FPE. With FPE, the encrypted values have the same overall format as the unencrypted data. This feature means you do not have to change the data types of table columns that you want to encrypt. It also preserves reference integrity. The encrypted values have the same sort order as unencrypted ones, and encrypted values can be cross-referenced between tables as long as each instance of the value is encrypted with the same key. Encryption uses cryptographic algorithms and keys, and the proper management of cryptographic keys is essential to effective use of encryption. Poor key management can make strong algorithms useless. Modern strong encryption is never cracked, but often bypassed. It doesn't matter how much encryption is done. If keys are not well protected, it takes little for a hacker to obtain the crown jewels with significant business and reputational impact. Key management is just as important as implementing strong cryptography and is all too often the Achilles heel of enterprise data security and privacy programs. Unlike legacy key management solutions that require complex replication and scaling architectures, Voltage SecureData provides stateless key management that enables on-demand key generation and regeneration without an ever-growing key store. The result is a system that can be infinitely scaled across distributed physical and logical locations with no additional overhead. Voltage stateless key management eliminates operational complexities, guarantees keys cannot be lost, which is vital for global organizations. Secure data is based on highly available distributed architecture and provides keys automatically with no key storage or database management issues, such as key rollover, backup, recovery, and audit. Stateless key management can be linked to existing identity management infrastructure, including roles and groups. Permission to decrypt or detokenize can be assigned to an application or user basis, and it can be managed through external LDAP directories, taking advantage of LDAP groups to simplify user management. Here you see the illustration of format-preserving encryption. Two cases are shown. One where the key is not preserved and another where it is preserved. As you see, the encrypted credit card number has the same format as the unencrypted one. Let's take a closer look at voltage secure data and Vertica integration. Vertica provides functions to encrypt and decrypt data using secure data. A special connector that calls the secure data API enables two things. First, encrypt sensitive data as it has been loaded into Vertica. This data is called encrypted at rest, and the authorized users can decrypt it. Decryption can be automated using views or access policies. And second, encrypt semi-sensitive data that is stored unencrypted in Vertica so that unauthorized users only see a masked version of the data. This is on-the-fly encryption, and it can be automated by using access policies. Which encryption method to select depends on the data. For example, regulations or contracts may require you to encrypt specific pieces of data. In these cases, use secure data to encrypt your data as it is loaded, so it is never stored in an unencrypted format within Vertica. Choose the method that requires the least number of encryptions or decryptions, and therefore of calls to secure data. If most of the queries on the data need to be masked from users who should not see the unencrypted values, then encrypt the data at rest. Alternatively, if the most of the queries will be from authorized users, with only occasional queries where the data should be masked, then store the data in an unencrypted format and use on-the-fly encryption to mask the data. Vertica instance using Federal Information Processing Standard FIPS is incompatible with the voltage secure data integration. In the future, Vertica will have even more efficient encryption at rest. It relates not only to voltage secure data integration, but to native or built-in encryption as well. Let's move on to the access control and take a look at how a user can prove who he or she is. Vertica supports several authentication methods, but which one to use depends on a particular case. The design of usable yet secure systems raises crucial questions when it comes to proper and reasonable balance between security and usability. Finding the right trade-off between these two quality attributes is not an easy endeavor. Attackers can abuse a system that is too usable but not very secure. In general, there is always a compromise between the ideally secure system and the ideal human-computer interaction, like shown on the diagram on this slide. Here is the list of the authentication methods built into Vertica. Trust method requires only a valid username, no password is required, and authentication is in fact not performed. Reject method enables to reject the connection from a user, providing an invalid name. Hash method sends the hashed password over the network, and those methods should only be used by small deployments, because usually a company has an LDAP server where they manage users, avoiding the duplication of users and passwords. LDAP method allows users to be managed centrally. TLS connection to LDAP server is supported. To set it up, use Vertica SQL like shown on the slide. Create authentication method granted to users. Kerberos Authentication is similar to LDAP, but more complex to set up. The huge benefit of Kerberos is that it allows to have single sign-on within an organization. It always requires a key distribution center, KDC, to which a user connects with the credentials and gets the ticket granting ticket, TGT. As shown on the slide, after a user gets the valid TGT, the client connects to KDC and gets a ticket to access Vertica within a particular session. A principal in Kerberos is a unique identity to which Kerberos can assign tickets. They should be created in the KDC for Vertica server, users, applications that connect to Vertica. Vertica supports X509 client certificates, which utilize public key infrastructure, PKI, in order to authenticate clients. Those certificates can be used simultaneously with one or other authentication methods or by itself. Users commonly generate a certificate for their non-user interface or script-based clients. The PKI certificates are used to manage identity and security in internet communications and computer networking. They are unobtrusive and ubiquitous, and we encounter them every day when using websites, mobile apps, online documents, and connected devices. Digital identities don't have to be restricted to devices. They can also be used to authenticate people, data, or applications. Digital identity certificates based on this standard enable organizations to improve security by replacing passwords, which attackers have become increasingly adept at stealing. Multi-factor authentication, MFA, provides a secure method for validating users on login. The full implementation of GDPR may soon make MFA a legal necessity for vendors doing business in the European Union. But Vertica already has a user authentication solution, so why use Kerberos instead of LDAP with Duo to set up MFA, you might ask? One answer is that it's more convenient for the users. The typical user authentication design, using LDAP, for example, frequently asks users to re-enter their credentials. Users understandably find these repeated requests frustrating. Kerberos solves the problem by granting a ticket generated from the user's credentials and an additional encrypted secret. Configure a proxy provides a second method of authentication by requiring a response from the user's mobile phone or another authentication device to fully authenticate the user. After the user is validated, the cached ticket gives the user 24 hours of access to the protected Vertica instance without further interruptions to re-authenticate. Additionally, setting up MFA using Kerberos instead of LDAP is more secure. That's because no passwords are sent over the network, and there are fewer places where passwords are written down on end-user computers. Duo is the highest quality video calling app. It's free, simple, and works on Android phones, iPhones, tablets, computers, and smart displays like Google Nest Hub Max. Duo provides the end-to-end encryption. The next question we should answer connecting to a database is what I am. Let's see how it's possible in Vertica. What I am is defined by the roles assigned to me. Since roles can be enabled and disabled at will, and multiple roles can be active, they provide a flexible way to only use the privileges you need in the moment. For example, Alice on this slide does not want to use the powerful DB admin privileges all the time. Set role enables a role for the user's current session. The user can access privileges that have been granted to the role. Enabling a role has no effect on roles that are currently enabled. The DB admin role is a predefined role that is assigned to the DB admin user during Vertica installation. We store that information in the catalog, the Vertica's metadata storage, and linked to the vCatalog schema within Vertica database, within Vertica instance. If an organization is small or only some people or services need Vertica access, users and roles should be managed with Vertica's SQL command, create, alter, drop user role. If the organization is big and wants Vertica to work with its centralized user management system, LDAP link is the solution. LDAP link enables synchronization between the LDAP and Vertica servers. This eliminates the need for you to manage two sets of users and groups of roles, one on the LDAP server and another on the Vertica server. With LDAP synchronization, the Vertica server becomes a replication database for the LDAP servers. With LDAP link, the Vertica server closely integrates with an existing directory service, such as Microsoft Active Directory or OpenLDAP. The Vertica server automatically synchronizes LDAP users and roles to Vertica users and roles. The LDAP link dry run meta functions allows you to configure the service in discrete stages before making any real changes to the database. Here is the example of how dry run can be used. To view the results of each dry run, we can run the system. We can query the system table LDAP link dry run events. This table clearly shows the results of a dry run, column called events types, and some additional information. We've seen how to answer the question of who or what I am. Now the question is, what can I do? Sometimes who you are defines what you can do. If you run create user, Vertica will check if you are the super user. Sometimes it's more complex, and Vertica has to check if the principal has the required privileges. The example SQL code on this slide shows which privileges are required to select a table or run a user-defined function. If an action requires a privilege, it can originate from different places, as shown on the diagram on this slide. Database users own the objects they create in a database, such as tables, procedures, storage locations, etc. By default, users have the right to create temporary tables in a database. By default, again, only an owner or super user can act on a database object. All non-database or non-DBA or super user or object owners are public users. That's goes by default within Vertica instance. Newly created users do not have access to the schema public by default. Make sure to grant usage on schema public to all users you create. Implicit privileges work through object ownership. Explicit privileges are assigned with grant statements on objects. And finally, inherited privileges is Vertica specific feature. By default, inherited privileges are enabled at database level, but it can be disabled. You can view your effective privileges on an object with a meta function getPrivileges description. Predefined database roles in Vertica are listed on this slide. The roles can be granted automatically, like during the Vertica installation, following is granted. Roles DB admin, sudo super user, and DBD user are irrevocably granted to the DB admin user. These roles are always enabled for DB admin and can never be dropped. Public is granted to DB admin and to all other users as they are created. This role is always enabled and cannot be dropped or revoked. Users with sudo super user role are entitled to complete administrative privileges which cannot be revoked. The sysmonitor role enables viewing all system tables that are marked as monitorable. Let's review the example scenario. I have a really big schema with lots of objects. For each user, I want the privileges for all tables and views in the schema to be the same. Approach 1 here can be remember to run grants every time a new table or view is created, but it is a huge pain. And approach 2, which solves the problem, is use schema inherited privileges. Vertica allows to manage inheritance of privileges at 3 levels: database, schema, objects, tables, and views. On database level, we just enable it. By default, inherited privileges are disabled at the schema level. We enable them by running create alter schema SQL commands, like shown on the slide. Unless explicitly excluded, privileges granted on the schema are automatically inherited by all new tables and views in it. This mechanism does not work for user-defined functions. Inheritance can be set per table or per view basis, and schema default is only for new objects in the schema. Remember to alter table view for already existing relations. To monitor privileges, three system tables are available: grants, inherited privileges, and inheriting objects. For the current user, sum up all privileges with a single meta function. Get privileges description, which is very, very convenient. Select lets you see everything or nothing. But what if I want some users to see a subset or transformed version of the data? I could make a view for each user, or I could use access policies. This is much more powerful option. Access policies can do this without introducing new objects or dependencies, centralizing the restriction logic and management. Access policy defines how much data certain users and roles can query from a table. It can be applied to tables, columns, and rows, even at the same time. If this is the case, Vertica filters rows first and columns after. Access policy can be set for a table of any type, regular, external, flex, etc. Using access policy, you can hide or transform data in a row or column, depending on who is running select. If access policies let you see the raw data, you can still modify the data. To monitor access policy, the system table access policy can be used. In client-server scenarios, it is common for one server to call another server to accomplish some task on the client's behalf. The situation where a server is given the authority to act on the client's behalf is called delegation. From security standpoint, two issues arise regarding delegation. What should the server be allowed to do when acting on the client's behalf? And second, what identity is presented by the server when it calls other servers on behalf of a client? Let's see how things are here with Vertica. An example of the delegation is access to a cloud storage. With most services, we do the permission check ourselves and then connect as Vertica, like in this diagram. Sometimes we can do better. Instead of connecting as Vertica, we can connect with some kind of upstream user and identity. When we do that, we'll let the service decide who can do what. So Vertica isn't the only line of defense. This option brings us big benefits for auditing, because the external system can see who really was doing something, not just Vertica. Let's see how delegation works with voltage secure data and consider the options. First, when I'm just encrypting for compliance or anti-theft reasons, the solution would be to use one global identity to encrypt and decrypt with voltage. And second, when I want to control which users can decrypt which data, the solution would be to give voltage users access to appropriate identities, which control encryption for sets of data. A voltage user can access multiple identities, like groups. Vertica users can set their voltage credentials in Vertica. Vertica talks to voltage as that voltage user. Vertica can store and interact with data on non-local file system like HDFS or object storage or of various flavors. Sometimes, like in Aeon mode, when compute resources are separated from storage, Vertica natively stores and manages its data in those file systems or on communal storage. But sometimes Vertica is interacting with external data in, for example, ORC or Parquet format on HDFS or on object storage. It's not really Vertica's data. We don't want to give Vertica more power than it needs, so the data should be requested on behalf of those who really need it. To set up a storage location, we run create location Vertica SQL command, taking into account the predicted or measured access patterns. Or we create a special storage location for specific users or user groups. If we need to copy from Parquet or export to Parquet a Vertica table in my own S3 bucket, we have two options. First, to give Vertica as a whole access to the bucket, which is problematic from the security perspective. Second is to use an ID and secret key pair through an AWS principal that does have access to the bucket. The access can be set on a session level, providing even more security. In our roadmap, we plan to support for keyless delegation using assumable IAM roles. We can do the same for HDFS using the following Vertica features: secure impersonation, which uses a high privilege shared Vertica user. Here we impersonate the communication with the HDFS by setting up a special identity, not the current Vertica user or a proxy user who works with or without Kerberos. We can use the Vertica user's Kerberos ticket to talk to downstream HDFS as that Kerberos user. It is related to Vertica GitHub versus user's Kerberos identity. Like with S3, Vertica users can bring their own delegation tokens and use them during a Vertica session. The closing topic of this session is about how we can monitor what we've discussed. The question we will answer is what's happening, sometimes what's up. Vertica is the most transparent database as far as monitoring goes. The system information is split into two parts: data dictionary like Vertica object definitions, etc., are stored in the Schema V catalog, and monitoring information in Schema V monitor. But metadata is sensitive too. That's why the principle of least privilege would be the most reasonable one. Only those who need the auditing monitoring information should be authorized to access it. Pseudo superuser sees all metadata, including sensitive configuration parameters. To manage the way how other users can access the required Vertica information, Vertica provides sysmonitor role, and the meta functions restrict and release system table access. Sysmonitor role provides the privileges to view all system tables that are marked as monitorable and can be granted to a user with admin option. Release restrict system table access meta function enables non-super user access to all system tables. Neither of those options can be configured for a specific preset of tables. They give overall access. For full control over metadata, use grants. Don't bother with sysmonitor of functions. Grant whatever privileges you see fit the roles you create and revoke access to public. If you need fine-grained access, you can create views on system tables. For example, you can create a view on top of the user's system table, which only shows the current user's information. Super users and those with file system operating system access have more ways to monitor Vertica's events. The main log in Vertica is vertica.log, stored in the catalog folder of each of the servers of the cluster. Before vertica.log has been initialized to write messages, each node in the cluster writes messages into a file named dblog. A whole lot of events can be tracked for SNMP if we configure Vertica accordingly. For example, low disk space, recovery failure, etc. The configuration steps include enabling Vertica to trap events, defining where Vertica sends the traps, and optionally redefining which SNMP events are tracked. syslog is a network logging utility that issues, stores, and processes meaningful log messages. It is a useful way to get heterogeneous data into a single data repository. To log events to syslog, enable event reporting for each individual event you want to be logged. Active events, a sensitive system table, stores all active events in the cluster along with their severity ranging from emergency to debug. Finally, the data collector collects and retains history of important system activities and records essential performance and resource utilization counters. Data collector extends system table functionality with minimal overhead. It sorts events by subject, component, and logs to rotating files. These files can be exported into a monitoring database supported by Vertica Management Console extended monitoring functionality. And that's it for the key points of Vertica, of security in Vertica. Many of these slides require a separate talk, so we encourage you to check out our blog, documentation, and forum for further investigation and collaboration. Hopefully, the information we've provided today will inform your choices in securing your deployment of Vertica. Please feel free to ask any questions you may have and enjoy the rest of the event. And with that, I'm handing over to Jeff for Q&A. Thank you very much.
Thanks, Andre, and thank you all for listening to our presentation. We are now ready for Q&A. Andre, nice job again with the presentation. We've been getting some good questions that have been coming in for you and Chris, so let's dig in. Okay, so the first one I see here is questions around voltage. Andre, you may have this one, and it's around licensing. How is the encryption with voltage licensed? Andre, is that yours?
Yeah.
Can you answer that one?
Yeah, that's. Thank you, Jeff. Yeah, that's a very important one. We need to understand that.
Right.
It's a separate license. It's a Vertica add-on SecureData add-on, and it's licensed separately because not at all the installations need that functionality, and also because it involves third-party application. The licensing strategy here is fairly simple. The license does not depend on the infrastructure, on the hardware. It doesn't matter how many nodes you will be using. It will only depend on the basic metric we have for Vertica as well, which is raw data size for the data which is stored within Vertica. And along with this license goes the license for voltage secure data appliance. We get two licenses for secure data key server, 2 licenses for voltage secure data web service server, and secure data API and file processor, both for Windows and Linux. They all go for free, but only to store and access the data which is stored within Vertica. So that's mainly the picture of how encryption, this encryption is licensed.
Great. Thanks, Andre. Very good. Lots of questions around voltage, which is good. Got another one that just came in. As far as I understand, ROS containers are already not human readable, maybe kind of encrypted. Is that true?
Yeah, I can take this one. So I really like this question actually, because it brings up kind of a fundamental principle of security, which is security through obscurity isn't really what we want. So it is correct. ROS files, they use multiple compression algorithms, and what you get is something that is not human readable data, right? You do need Vertica to interpret that data. But the algorithms weren't designed with true security in mind, right? If someone can figure out how the steps work, they can figure out how to reverse engineer that data into something that's human readable. So a key principle of real encryption is that even if you know every step involved in the process, there's a secret. And as long as that information is random or cryptographically pseudo-random, an attacker can't feasibly decrypt that data. So you shouldn't just depend on ROS files being weird and strange to secure your data. You should use something like voltage. We're also looking into ways for future releases to do it natively.
Very good, Chris. Thank you. Good, thorough answer there. Okay. Another one here is, how can we evaluate the perf degradation with internode TLS enabled?
Yeah, I can take that one. Obviously, as mentioned in the presentation itself, if we enable TLS for internode communication, then both spread data and Vertica data, which move between the servers and need connection from server to server within the cluster. All those processes will need additional overhead for TLS authentication. But obviously, both processes, they depend on the specific workload which you have in your solution. So it's unpredictable. The only thing which we can do here is simply to test, to take your typical workload, to disable TLS, run the workload, put down all the metrics you want to monitor and control, and then enable TLS and run the same. So that's the only way to evaluate. There is no generic rule or how you can forecast the performance degradation.
Got it. Okay, thank you, Andre. Okay, next one here is mutual mode authentication more widely used or is it rare? What are other alternatives in case we cannot implement it?
Yeah, I can take that. So I can't actually speak too much as to how common it is in the field. Andre would know more than me. But I have seen cases where customers definitely didn't want to have to make sure that every client has their own certificate set up, right? So it's important, I guess, to differentiate between authentication with TLS and confidentiality with TLS, right? So mutual mode, it means that not only does the server have a certificate set up, in this case Vertica, right, or each of the Vertica nodes, but also the client connecting to Vertica would have its own cert. That part, I would say, as long as you trust your network topology, and then there's nothing crazy going on. You could use a different authentication method, right? You could use Kerberos, you could use LDAP, you could use hash for Vertica managed passwords, and then still configure TLS to happen for the rest of the connection, right? So the data going over between the client, whether that's JDBC, vSQL, what have you, the data will be protected by a TLS because the server had the cert and that was verified by the client. But the authentication method was different, and that's okay. You can mix and match.
Very good, Chris. Thank you very much. Okay, we are getting out of time for questions here. Maybe just a closing remark, or maybe Chris or Andre, you can speak to it. There's a lot of questions around as far as encryption. How does it affect performance? Do you have just any general statements there? It's a couple of questions there. I'm just kind of summarizing because we got to wrap up with this one. Anything to end there?
Yeah. It definitely will. You can't get around it, but as to how much, I think Andre would probably know more about how you could measure performance than I would. Do you have any tips on that?
No, we don't have any particular figures from the field. But they'll, again, it all very much depends on your solution, on your workload. And while you are building your production system, you just need to test both options with encryption and without encryption. So that's the only obvious way we can recommend here.
Nope, and that's good. All right. Well, thank you both. I just wanted to just cover that last one there. But that's all the time we do have for questions today. Thank you, our audience, for your great participation. If we weren't able to answer your questions today, we'll do our best to respond directly via email. And again, our engineers will be in the developer lounge as well. Make sure you go to the developer lounge. And please note the replay of today's event. A PDF copy of the slides will be available on demand shortly. And of course, we invite you to share them with your colleagues. Again, thank you to our audience today. Don't forget to type the session code in the Analyze to Win section on the event navigation panel. Note that there will be a short message from our sponsors that I encourage you to stick around and catch after this. Now this concludes this breakout session. Have a great day. We hope you enjoy Vertica Unified 21.
We are at the age of data. Enterprises today still struggle to solve problems of the past. There are tons of commoditized solutions with lack of identity and value in the market. In Global Maximum, we do not believe in partial solutions. We provide tailor-made full-stack solutions on data warehousing, business intelligence, data analytics, and artificial intelligence. Simple, customized, and works like a charm. Contact us today to work with the best data engineers in the region and enjoy your business while we challenge your problems with our differentiating solutions.